Ladies and gentlemen, welcome to today's topic. Aliens. Are they real? Do they exist? And if so, what do they look like? Today, we will dive deep into the topic of aliens, exploring various theories and facts about these mysterious creatures. If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. Here are a few theories about aliens. 1. Extraterrestrial life exists. This is the theory that life exists elsewhere in the universe, perhaps even within our own solar system. Microbial life could potentially exist on Mars or some of the moons of Jupiter and Saturn, for example. More complex life forms, such as intelligent civilizations, could also exist on planets orbiting other stars. 2. The Fermi paradox. The Fermi paradox suggests that if intelligent life is common in the universe, why haven't we detected any evidence of it? Some theories suggest that intelligent civilizations tend to self-destruct, while others propose that they are too far away or have no desire to communicate with us. 3. Ancient aliens. This theory suggests that aliens have visited Earth in the past and have influenced human history and culture. Proponents of this theory point to ancient artwork and texts as evidence of alien visitation. 4. UFO sightings. Unidentified flying objects are often cited as evidence of alien visitation. While many sightings can be explained by natural phenomena or human-made objects, some remain unexplained and could potentially be evidence of extraterrestrial visitation. 5. The simulation theory. This theory proposes that our entire reality is a computer simulation created by an advanced civilization. While not specifically about aliens, this theory suggests that the creators of the simulation could potentially be an extraterrestrial civilization. To start with, let's address the most basic question. Do aliens exist? Well, according to the Drake equation, which was developed in 1961 by astronomer Frank Drake, the probability of intelligent life existing elsewhere in the universe is high. The equation takes into account factors such as the number of stars in our galaxy, the number of planets that could potentially support life, and the probability of life forming on those planets. Using these factors, the Drake equation estimates that there could be millions of intelligent civilizations in our galaxy alone. But the question remains, have we ever encountered these civilizations? Many people believe that we have, and there are countless stories of alien sightings, abductions, and encounters. However, there is little concrete evidence to support these claims. So, let's explore some of the most popular theories about what aliens might look like. The traditional image of aliens as small, green, big-eyed beings is a product of popular culture. However, it is unlikely that aliens would look anything like this. In fact, it is impossible to predict what aliens might look like, as their appearance would depend on the conditions of the planet they evolved on. For example, if an alien species evolved on a planet with high gravity, they might have shorter, stockier bodies. If they evolved on a planet with a harsh, radiation-filled environment, they might evolve to be more resilient to radiation. It's also possible that some alien species might not even have bodies as we know them. They might exist as pure energy or as a hive mind collective. But why would aliens visit Earth? There are a few possible reasons. Some scientists speculate that aliens might be interested in our planet because of our planet to learn more about how life can survive in these conditions. Another reason aliens might visit Earth is to make contact with us. If there are millions of intelligent civilizations in the galaxy, it's possible that some of them are trying to communicate with us. However, if this is the case, they might be communicating in ways that we can't even comprehend. Their methods of communication might be vastly different from ours. So, what should we do if we ever do encounter aliens? Many scientists believe that we should approach any encounter with caution. We should avoid making any sudden movements or aggressive actions, as these might be misinterpreted by the aliens. Instead, we should attempt to communicate in a peaceful and non-threatening manner. If we do make contact with aliens, it could have profound implications for our understanding of the universe. It could challenge our beliefs about our place in the cosmos and force us to confront some of the big questions about life, the universe, and everything. Now that we've explored some of the theories and possibilities of alien life, let's consider the idea of the Fermi paradox. This paradox asks the question, If there are so many intelligent civilizations out there, why haven't we seen any evidence of them? Why haven't we detected any signals or observed any spacecraft from other worlds? One possibility is that advanced civilizations tend to self-destruct. With technology comes the potential for destruction, whether through environmental damage, war, or some other catastrophe. It's possible that many intelligent civilizations reach a point where they are unable to sustain themselves and ultimately fail. Another possibility is that intelligent civilizations have no desire to make contact with us. Perhaps they are simply not interested in Earth or in communicating with other species, or perhaps they are too far away to detect our signals and we are too primitive to detect theirs. Regardless of the reasons, the Fermi paradox remains a mystery and a subject of much speculation. But let's turn our attention to the possibility of life in our own solar system. While we haven't found any evidence of intelligent life, there are some promising signs that microbial life might exist on other planets or moons. For example, NASA's Mars rover has detected methane on the planet's surface, which could be a sign of microbial life. Scientists have also found evidence of subsurface oceans on some of Jupiter and Saturn's moons, which could potentially support life. If we do find evidence of microbial life in our own solar system, it would be a major discovery and could have significant implications for our understanding of life in the universe. Let's consider the potential implications of discovering intelligent life. If we were to make contact with an alien civilization, it could have profound impacts on our society and our understanding of the universe. For one, it could challenge our existing beliefs and worldviews. We might need to reevaluate our ideas about our place in the cosmos, our religious and philosophical beliefs, and our understanding of the origins of life. It could also raise questions about the ethics of interacting with other intelligent species and the responsibilities that come with such interactions. Another potential impact is on our technology and scientific progress. If we were to encounter a more advanced civilization, we could learn from their technology and knowledge, potentially accelerating our own progress. On the other hand, it could also pose a threat if the aliens have hostile intentions towards us. It's difficult to say for certain whether aliens, if they exist, would be dangerous to us. We have no concrete evidence of intelligent extraterrestrial life, and so any speculation about their intentions or behaviors is purely hypothetical. Some people argue that aliens could be dangerous if they are more technologically advanced than us and have the ability to conquer or destroy us. Others point out that any civilization advanced enough to travel through space would likely have a more sophisticated understanding of the universe and may be more peaceful and cooperative. It's also possible that aliens could be indifferent to us, simply observing us from a distance. While it's fun to speculate about the potential dangers of alien life, the truth is that we simply don't know enough to make any definitive conclusions about their intentions or behaviors. The search for extraterrestrial life should be approached with an open mind and a healthy dose of curiosity rather than fear or paranoia. Regardless of the potential impacts, the search for intelligent life continues. We are constantly developing new technology and refining our techniques to search for signals and evidence of other civilizations. And while the chances of finding intelligent life may be slim, the pursuit of knowledge and discovery is a worthy endeavor in and of itself. The hypothesis of natural filters in the universe posits that advanced extraterrestrial civilizations may have existed for a long time, but were eradicated by these natural filters. If extraterrestrial life exists, the question arises whether their forms and environments would be similar to those on Earth. And environments might not necessarily resemble those on Earth. Life could evolve in diverse ways, depending on the unique conditions of each planet. The variety of planetary environments and the adaptability of life make it plausible that extraterrestrial beings might have different biochemistries and physical characteristics. Rocky planets like Earth are considered ideal for supporting life due to their specific conditions. However, these planets are delicate and susceptible to various threats, and this fragility means the universe could filter out intelligent life quickly. One significant threat comes from violent stellar events, such as gamma-ray bursts, which are powerful enough to sterilize planets over vast cosmic distances, potentially affecting entire galaxies. Imagine this: a huge star explodes in our galaxy, the Milky Way, sending a deadly burst of energy hurtling toward our planet. This is a gamma-ray burst, the biggest blast since the Big Bang. There are no signs that something bad is about to happen, and then it strikes. The radiation that is pumped up heats up the high atmosphere. Our layer of ozone heats up across the atmosphere, and human beings burn to death from radiation 100 times the fatal dose. When the ozone layer gets thinner, temperatures rise all over the world. This makes storms, tsunamis, and hurricanes happen, and most life on the surfaces of land and water incinerates. This may sound like science fiction, but if a gamma ray burst from 100 light years away hit Earth, it could happen. Even if intelligent species manage to survive these natural occurrences, there is another risk: self-destruction. Drawing from our own experiences on Earth, the development of technology has given us the capability to alter our climate and create weapons of mass destruction. This self-destructive potential poses a serious risk for advanced civilizations. It is plausible that technologically advanced societies may have a brief existence, as evidenced by our own history. The short lifespan of advanced civilizations could be a reason why there are so few observable ones at this point in time. The possibility arises that many civilizations may have emerged, but their existence was short-lived due to self-inflicted challenges. This scarcity of long-lasting civilizations could explain the limited opportunities for communication with extraterrestrial beings. Discovering remnants of an extinct alien civilization could serve as a profound warning for humanity. If we were to find evidence of a civilization that destroyed itself through pollution or conflict, it would be akin to looking at our own potential future. This sobering realization could provide valuable lessons for us on Earth, emphasizing the importance of avoiding similar pitfalls in our quest for understanding the cosmos. We can only hope that some advanced alien species have managed to navigate the challenges posed by the universe's potentially lethal filters, offering a glimpse of long-term survival and prosperity. If we are lucky, there may be an extraterrestrial civilization that will come to visit us in the future. Imagine making contact with aliens. Sounds cool, right? But hold on, are we assuming too much? We tend to think that aliens are just like us. But here's the twist: they're not. We might be imagining them based on what we know about life on Earth, assuming they live on planets like ours. But guess what? Most of the universe might not follow our life and planet rulebook. So could extraterrestrials even survive first contact with us on our planet? In July 2019, a satellite on a test mission spotted a new alien world named GG357, about 31 light years away. This super-Earth is over 6 times heavier than our cozy home planet. Now, what's a super-Earth? It's a terrestrial planet, gravity, creating a whole different vibe compared to our Earth. Imagine aliens living on a super-Earth. The gravity there could be super strong. They might not be tall, but I bet they'd be super strong. Super-Earths are just one of the many wild things the universe cooks up. Who knows what other surprises are out there? The possibilities are as vast as the cosmos itself. The universe is a vast playground, with planets of all shapes and sizes orbiting stars of various types and sizes, forming countless configurations. This diversity opens up a world of possibilities for life that is much richer and more varied than we ever imagined. However, we need to break free from the idea that extraterrestrial life will resemble us. If we're expecting beings with 2 legs like ours, we might as well abandon that notion. The truth is, life out there could be radically different. Consider this scenario: an intelligent alien species in our cosmic neighborhood wants to say hi to us. Ecosystems. When it lands on Earth, it's a cosmic mystery waiting to unfold. Is it possible for science fiction to become reality? I believe the reason Hollywood is so interested in the prospect of first contact with aliens is simple. It would be the biggest scientific discovery in human history. The problem is that our cosmos erects enormous hurdles to encountering extraterrestrials. It's almost as if the cosmos is trying to keep us from establishing first contact on purpose. We're looking for answers in the universe. Will we ever discover intelligent extraterrestrial life? Or are we alone? Our Arecibo Observatory blasted a strong radio message deep into space 45 years ago, launching our efforts to make first contact. The Arecibo transmission was the first communication or effort to connect with a hypothetical civilization outside our galaxy. That communication is currently en route to the M13 galaxy cluster, which is about 25,000 light years distant. It carries data about our planet, our location, and even the composition of our DNA. The goal of this communication was, of course, to say hello and also to raise the question, are we alone in the universe? But how likely is it that an intelligent alien culture is waiting for our message? Do you believe there is intelligent life in the universe? The answer is a loud yes. We know that life originated on Earth almost as soon as our planet formed, so why wouldn't it have occurred someplace else? How many extraterrestrial civilizations may we possibly contact? Frank Drake, an astronomer, devised an equation to assist in answering this critical topic. The Drake equation is a really remarkable effort to apply mathematical logic to the likelihood or potential of life beyond Earth. They'd also projected that there were about 10,000 intelligent civilizations in our galaxy. Since the Drake equation was initially developed, our knowledge of the galaxy has changed dramatically. Exoplanets are worlds found beyond our solar system. There are about 4,000 of them now known, and techniques are finding more every day. Scientists think that what we've discovered is only the top of the iceberg. Even though life is very uncommon, there are many opportunities for it to emerge throughout the cosmos. As a result, it is quite possible that there is reasonably plentiful life in the cosmos, including an uncountable number of sophisticated extraterrestrial civilizations. This isn't science fiction, it's just basic probability. Most likely, there are many different alien cultures out there. So, don't you think it's a little strange that we haven't met yet? I think there are good reasons to think there are civilizations out there. Why haven't we found any other societies? One answer could be the sheer vastness of the cosmos. The galaxy is very big. Even if there are 10,000 civilizations in the galaxy, it's possible that the distances between the stars are so great that we'll never be able to talk to each other. So, imagine we send a message into space 45 years ago, hoping to reach any potential aliens out there. Well, guess what? That message is still super far away from its destination because it's cruising at the speed of light. The place we're trying to reach is a whopping 25,000 light years away. The vast size of the universe is a huge roadblock to making first contact, and that's a bit of a problem when it comes to reaching out to potential extraterrestrial buddies. The laws of physics are like a roadblock preventing radio signals from zooming across such vast distances. Turns out you can't break the speed limit of light. But fear not, we're not giving up. In fact, we're using the best tech on Earth to speed up the search. The Breakthrough Listen project is our superhero in this quest. Imagine high-tech facilities worldwide, radio telescopes, optical telescopes, on the 1 million stars and 100 galaxies closest to us, making it the most epic search for alien chatter ever. So, if there's an alien aircraft around any of the 1,000 nearest stars, the Breakthrough Listen project is on it like a detective. They got the tools to catch any signals and make sure we don't miss out on intergalactic conversation. Cool, right? Breakthrough Listen is like a cosmic detective trying to catch any signals from outer space. Right now they're eavesdropping on the closest 17 stars to us, hoping to hear something exciting. But guess what? It's been pretty quiet so far. It's kind of like waiting for a phone call that never comes. It's frustrating because we haven't found any proof of alien civilizations yet. But here's the catch. Just because we haven't heard anything doesn't mean they're not out there, allowing us to evolve into a smart species. But in the grand scheme of the universe, we're just cosmic toddlers. Earth is super old, like over 4.5 billion years old. And guess what? It took all this time for us humans to become the cool, tech-savvy civilization we are today. But here's the kicker. There are star systems out there that have been around even longer than us. The universe itself is a whopping 13.8 billion years old. Wrap your head around that. We often think we're top-notch because we can build rockets and play with radio waves. However, if we met a civilization that's been around way longer than us, they'd probably be light years ahead in technology. There's this cool way of measuring how advanced a civilization might be. It's called the Kardashev scale. It sorts civilizations into 3 types based on how much energy they can grab from their surroundings. Type 1 can only use the energy of its home planet. Type 2 could potentially harness the energy of its entire solar system. And Type 3, well, they're the big shots who could harness the power of a whole galaxy. But here's the buzzkill. We're not even a Type 1 civilization. We're somewhere between 0 and 1 on the scale. We can't fully tap into all of Earth's resources, so we're sitting at a modest 0.7. But hey, we're trying our best to catch up with the cosmic neighbors. Imagine an advanced civilization hitting Kardashev level 2 or 3. These guys could create mind-blowing structures that tap into the power of a star, massive solar panels enveloping the entire star, a concept first dreamed up by Freeman Dyson. These cool structures are called Dyson spheres. Now, if other star systems or even entire galaxies have these epic Dyson spheres, could we catch a glimpse and finally make contact with these advanced beings? Here's the deal with Dyson spheres. They block almost all the light from a star except for the sneaky infrared light. Why? Because those panels are soaking up sunlight and getting warm, and when things warm up, they give off thermal infrared light. So we can play cosmic detectives by scanning the skies for this telltale thermal infrared signature to spot Dyson spheres. Back in 2015, NASA's Wide Field Infrared Survey Explorer scanned 100,000 nearby galaxies on the hunt for these advanced civilizations. They detected nothing. But here's the cosmic conundrum. The universe is crazy old, right? So, shouldn't other civilizations have had plenty of time to evolve? Well, maybe we just haven't noticed them yet. Imagine this. They're out there trying to send us a message, but it's like they're knocking on our door before our house is even built. Earth has been around for less than a third of the universe's 13.8 billion years, and humans, we've been strutting our stuff for just 300,000 years. That's a tiny window in the grand scheme of the cosmos to make that first contact. It's like trying to join a party, but you're fashionably late, and the party's been going on for ages. We inhabit a galaxy known as the Milky Way, which contains hundreds of billions of stars. How did we arrive at this point, and what is our future? These concerns involve galaxies in every aspect. The known universe contains 200 billion galaxies, each of which is unique, immense, and dynamic. Where do galaxies come from? How do they work? What is their future, and how will they die? If you are interested in amazing videos about the universe, be sure to subscribe to our channel to stay updated. This is the Milky Way, our galaxy, approximately 12 billion years old. The galaxy is a vast disk with enormous spiral arms and a central nucleus. It is only one of countless galaxies in the universe. Galaxies are massive assemblages of stars. First and foremost, a typical galaxy could contain 100 billion stars. They are actually stellar nurseries, the locations where stars are formed and perish. The stars in a galaxy are formed in nebulas, which are concentrations of dust and gas. Our galaxy contains billions of stars, many of which have planets and moons orbiting them. But for a very long time, we knew very little. Seems enormous from Earth, but compared to other galaxies, it's rather small. For instance, Andromeda, the closest galaxy to us, is about 200,000 light-years wide, twice as large as the Milky Way. M87 is even bigger, and 10 to 11 is the largest galaxy ever found, being 60 times the size of the Milky Way. Galaxies originated from the early universe after the Big Bang, forming from stars and evolving through gravity. The Hubble Space Telescope enables the observation of early galaxies, and it has found that galaxies have evolved from chaotic formations to orderly structures over billions of years. One key aspect of galaxy formation is the presence of supermassive black holes at their centers, with their gravitational effects shaping the galaxies around them. The Milky Way also hosts a supermassive black hole at its core, but there's no danger of Earth being sucked into it. Overall, galaxies have evolved over billions of years, shaped by gravity, star formation, and the presence of supermassive black holes at their centers 25,000 light-years. That's many trillions of miles. For the time being, Earth is secure. Although supermassive black holes are the source of enormous quantities of gravity, they are not strong enough to bind galaxies together. In reality, the rules of physics dictate that galaxies should accelerate away from one another. So what's stopping them? Because there's something stronger than a gigantic black hole waiting to be discovered. It is invisible and very difficult to detect. It's called dark matter, and it's everywhere. Supermassive black holes discovered by astronomers are found in the centers of galaxies and are responsible for the rapid movement of stars in their vicinity. However, they are insufficient to hold together all of the stars in a vast galaxy. So what does hold them together? It was a mystery until a maverick scientist proposed that something unknown was in action. Fritz Zwicky, a Swiss astronomer, pondered in the 1930s why galaxies clustered together. He reasoned that because they weren't producing enough gravity, they should be flying apart. However, the force of our own gravity was insufficient. Therefore, he deduced that it must be something that had never been discovered before, something that had never even been considered, and he called it dark matter. Fritz Zwicky was decades ahead of his time, and that's why he graded on the astronomical community. And this is a brilliant idea, but he was correct. You know, it's possible that individual galaxies are also held together by the mysterious substance, the Zwicky dubbed dark matter. Galaxies rely on dark matter as a kind of protective framework that keeps them from collapsing and moving about. Now, scientists have discovered that dark matter does more than just bind galaxies together. It may have also triggered their revolution. Scientists believe that after the Big Bang, dark matter started to cluster, and these dark matter clumps evolved into the galaxy's nucleus. However, the nature of dark matter is still a mystery to physicists. Weird things happen with dark matter. Since we don't know what it is, obviously, it's not constructed from the same substance that humans are. You can't push against it, you can't feel it. However, it is likely everywhere. It's a ghost-like material that will pass right through you as if you didn't exist at all. Although our understanding of dark matter is limited, it seems to be abundant across the cosmos. That means there must be at least 6 times as much dark matter as regular matter what humans are comprised of in the cosmos, and the way the cosmos seems to function depends on it. Observations of its effects on light have led to its recent indirect detection in deep space through a process known as gravitational lensing. It warps the light. The existence of dark matter may be tested using gravitational lensing. As a ray of light from a distant galaxy travels towards us, its course will be bent around a huge collection of dark matter due to the latter's greater gravitational attraction. Some distant galaxies indeed seem stretched and warped when seen via the Hubble telescope. The picture distortion is due to the presence of dark matter. We can determine the density of dark matter by carefully examining the forms and degrees of distortion of these galaxies. Now, more than ever, the importance of dark matter to the cosmos is undeniable. It's what makes galaxies form. Undetectable dark matter rules the cosmos. These galaxies seem to be completely alone. It's true, they are trillions of miles apart, but actually, they live in groups called clusters, and these clusters of galaxies are linked together in superclusters containing tens of thousands of galaxies. The Milky Way's place in the cosmos remains a mystery. If you look at the overall image, you'll see that our galaxy is associated with a smaller group of galaxies, including about 30 members in total, and that our galaxy and Andromeda are the 2 largest members of this group. Further observation reveals, however, that our galaxy is embedded inside the Vigo supercluster. Researchers are now making maps of galaxy clusters and superclusters to better understand the cosmos. Galaxies are the immense star empires. The shapes range from enormous balls to intricate spirals. The problem is that they are always evolving. When we stare out into the cosmos, it's easy to assume that our galaxy hasn't changed in eons. It's not. The Milky Way is a dynamic galaxy. Over cosmic eons, its basic nature has been changing. Galaxies don't only evolve, they move as well, and sometimes they run into each other. The 2 galaxies will merge over millions of years when they collide. This kind of collision occurs all the time in the cosmos. Our own Milky Way is no exception. We are on a collision course with the galaxy Andromeda, and that's terrible news for the Milky Way. The Milky Way galaxy are ripped apart, or we could wind up in the stomach of this new galaxy. Stars and planets will be pushed all over the place, so this may well be the end of planet Earth. Galaxies all over the universe will continue to collide, but this age of galactic cannibalism will eventually pass, because there is an even more destructive force in the universe, a force that nothing can stop. It will eventually tear the cosmos apart by stretching everything to the point that galaxies are pushed apart from one another. Researchers have identified a new cosmic power. It's called dark energy. Unlike dark matter, dark energy has the opposite effect. It pushes galaxies apart rather than bringing them together. Dark energy, which we've only discovered in the last decade and which dominates the universe, is significantly more enigmatic. We don't have the slightest idea why it's there, what it's made from. We don't really know. We are aware of its presence, but beyond that, our understanding of it is limited. Dark energy is really weird. Things resist and are pushed away from one another as if space itself contained tiny springs. In the far future, scientists predict that dark energy will triumph over dark matter in the cosmos, and with that triumph, galaxies will finally begin to drift apart. Galaxies will eventually die off due to dark energy. It will do this by accelerating the expansion of the universe, forcing all galaxies to recede farther and farther away from us until they become invisible and travel faster than the speed of light. Therefore, everything else in the cosmos will vanish before our own eyes. The remainder of the cosmos won't vanish today or tomorrow, but it may after 1 trillion years. Galaxies will be left alone in the void. However, this will not occur for an extremely lengthy period. The cosmos is doing well right now, and galaxies are creating favorable circumstances for life to exist. Without galaxies, I wouldn't be here, you wouldn't be here. Maybe not even life itself would exist. This is a lengthy text, and further information or assistance can be provided if needed. Different ways, based on how the ingredients are mixed and how hot the oven is. You mix the ingredients just like you did with the cake. Then you put it in the oven and bake it, and it would change. So basically, this is what happened in the solar system overall. The planet cooks in a slightly different way depending on how close it is to the sun. Near the sun, where it is hot, gases are burned off and water boiled away. Only materials that stay solid at high temperatures, like metals and rocks, can survive. This is why only rocky planets form close to the sun. As a planet moves farther away from the sun, it cooks in a different way. But what kind of planets will form depends on what's in the cloud. Based on what kind of cloud a solar system forms in, it might not have any rocky planets because it didn't have enough materials to make something like Earth. Instead, it might have more gas of rock. You need a cloud full of metals and rocks. The next step is to turn down the heat. As it cools, some of the things in it that have a high boiling point start to condense out as solids. These very small mineral grains can start to form. These tiny pieces of rock and minerals are the beginnings of a new rocky world. They start to stick together over time. If you had one dust molecule and another dust molecule, they would basically hit each other and make one slightly bigger dust molecule. And they keep getting more and more. This process is called accretion. As these things got bigger, they became basically rocks. Then rocks slam into other rocks and form boulders. Boulders smash together to form bigger boulders. At some point, you'll have something big enough that its weight is strong enough to start pulling things towards it. So instead of just crashing into things and getting bigger that way, it was actively pulling things in. At first, there were a lot of young planets in our own solar system, maybe 100. Most of them didn't make it. If you go to the asteroid belt and look at the asteroid Vesta, you can get a good idea of how big a hard planet has to be before it can pull itself into a sphere shape. Vesta is only 329 miles across, which isn't quite big enough to be a sphere. To become round, a growing planet needs to be 500 miles across. Then it has enough gravity to crush it into a sphere. Any smaller and it stays in a regular shape. Every time a baby planet crashes into something, it makes it hotter and hotter until it starts to melt. Gravity is now starting to sort the heavy things from the lighter ones. Lighter things tend to float up and form a crusty layer, while heavy things like most metals fall down and form a much denser core at the planet's center. Finally, the young planets are starting to look like planets. But now they have to make it through a time of violence and destruction, a cruel time that will decide which planets will live and which will die. After the sun was made, all 8 of our planets came from the same cloud of dust and gas. But they turned out to be very different. There was no real plan for how each of the new planets should be made. They did follow the rules of physics and chemistry, but most of what happened was just a matter of luck. About 4.5 billion years ago, our sun was surrounded by about 100 young planets. It turned into a demolition derby, Planet hit planet and most were wiped out. The early history of these planets would have been very, very violent, with many of these collisions happening in the last stages of each planet's growth. As these collisions happened and things ran into each other, some of the planetesimals started to grow at the expense of the others. And these things that would eventually become planets grew and grew. As they got bigger, they sucked up all the smaller planetesimals around them, which caused a lot of space debris to hit the surface of the protoplanet. After it was over, there were only 4 different rocky planets left. Because of the things that happened to each planet in the past, they are all so different from each other. Mars is a frozen wasteland. Earth flows with liquid water. Venus is a place full of volcanoes, and Mercury is small, empty, and very hot. Because of a huge crash, Mercury, for example, has a very thin crust and is very dense, so it could have been a bigger planet in the past. Then something hit it at an angle, which tore off the lighter crust and left only the dense center. Also hit hard was the young Earth. The survivors received additional ingredients, resulting in the separation of metal-rich components to the core and lighter, icy elements to the crust. Near the Sun, 4 rocky planets with solid iron cores, surrounded by liquid iron and molten rock, formed differently in size and destiny. The solar wind, a stream of hot, charged particles, is generated by the Sun's strong magnetic fields and poses a threat to astronauts. However, the Earth's magnetic field protects against the solar wind, preventing it from reaching the atmosphere and surface. Mars, once similar to Earth, is now cold and dry. Evidence suggests that water was once present, indicated by signs of past surface water flow and ripples. While Mars likely had a hot iron core and a magnetic field in its early history, it lost its magnetic shield as it cooled, allowing the solar wind to strip away its atmosphere and water. The gas giants Jupiter, Saturn, Uranus, and Neptune, located farther from the Sun, formed from dust and gas, including frozen water ice, leading to the growth of massive cores and the development of thick atmospheres. These outer planets' distance from the Sun allowed for the accumulation of ice and gas, resulting in their significant size. And this is what made up their moons. Each of Jupiter and Saturn has more than 60 moons. The gas planets have something else that makes them unique: rings. Saturn is different from the other planets because it has these beautiful rings. It turns out that Jupiter, Uranus, and Neptune also have rings, but they are very weak and hard to find. But they are there. There are rings around all 4 of the gas giants, but Saturn's are the most obvious. From far away, Saturn's rings look like a single flat disk, but in reality, they are made up of thousands of small rings that are only a few miles wide each. When the Cassini probe flew by, it found that billions of pieces of ice and space debris were moving around inside the rings at up to 50,000 miles per hour. These pieces of ice and rock hit each other all the time. Some of them turn into small moons, and some of them fall apart. But they never grow bigger because Saturn's huge gravity pulls them apart. Scientists are just now starting to figure out how the rings came to be. The idea is that a comet hit a moon and knocked it out of its orbit, bringing it closer to the planet. Saturn's gravity tore it to pieces. All of that stuff got stuck in rings that went around the planet. But the real mysteries of the gas giants are deep inside them, tens of thousands of miles below the clouds. Here is where things really get going. It's a place so extreme that it goes against the natural laws. Most of the new planets we find orbiting faraway stars are huge gas planets. They are so big that Jupiter seems small next to them, but nobody knows what happens inside gas giant planets, whether they are in our solar system or far away. We know that Jupiter's thick atmosphere goes down 40,000 miles, and we can see bands of gas moving at high speeds that make violent storms on its surface. But we don't know what's happening inside, far below the storms. NASA sent the Galileo spacecraft on a 14-year trip to Jupiter to find out. On December 7, 1995, Galileo sent a probe into Jupiter's atmosphere, which it did at a speed of 160,000 miles per hour. As it fell through the thick air, the parachute slowed it down. It saw lightning in the clouds and 450-mile-per-hour winds. The probe transmitted data back to Earth for 58 minutes. What happened to the Galileo probe that we dropped in? It didn't hit anything, It just kept falling into Jupiter's environment, and the pressure kept going up and up and up as it fell. It measured pressures 23 times higher than on Earth and temperatures over 300 degrees higher than on Earth. When you're in the environment of a gas giant and you go deeper and deeper into this soup of hydrogen, which has no solid surface, it can still be very heavy, and so eventually you would be crushed by the overlying weight of the material that's there. Even though the probe only went 124 miles down before it was crushed, it showed scientists what Jupiter's inside looked like. But the dark heart of the planet still remains a mystery. Like some rocky planets, the gas giants have a magnetic field too. Jupiter's magnetic field is 20,000 times stronger than Earth's and so big that it goes all the way to Saturn, which is more than 400 million miles away. Like on Earth, Jupiter's magnetic field keeps the solar wind away from the atmosphere and keeps it safe. When scientists looked at Jupiter's magnetic field, they found that it affected the moons of Jupiter. The volcanic moon Io orbits only 217,000 miles from the planet. Every second Io's volcanoes send a ton of gas and dust into space. It gets even stronger because of Jupiter's magnetic field, which makes powerful belts of radiation. And this makes the area around Jupiter very busy in a lot of ways. If you point a radio antenna at Jupiter, you can hear how the planets and the magnetic field interact with each other. Jupiter and Saturn can make auroras without the solar wind. They make their own magnetic fields because they're so big. These auroras show that planets with gas also have magnetic fields. But how do magnetic fields get made on gas planets? On Earth, the job is done by a very hot liquid metal that spins around the planet's solid iron core. Most likely, gas planets do about the same thing, but gas planets don't have iron cores that get very hot. They formed around frozen cores of dust and ice, so we don't really know. And this is what made up their moons. Each of Jupiter and Saturn has more than 60 moons. The gas planets have something else that makes them unique: rings. Saturn is different from the other planets because it has these beautiful rings. It turns out that Jupiter, Uranus, and Neptune also have rings, but they are very weak and hard to find. They are there. There are rings around all four of the gas giants, but Saturn's are the most obvious. From away, Saturn's rings look like a single flat disk, but in reality, they are made up of thousands of small rings that are only a few miles wide each. When Cassini probe flew by, it found that billions of pieces of ice and space debris were moving around inside the rings at up to 50,000 miles per hour. These pieces of ice and rock hit each other all the time. Some of them turn into small moons and some of them fall apart, but they never grow bigger because Saturn's huge gravity pulls them apart. Scientists are just now starting to figure out how the rings came to be. The idea is that a comet, a moon, knocked it out of its orbit, bringing it to the planet. Saturn's gravity tore it to pieces. All of that stuff got stuck in rings that are around the planet. But the real mysteries of the gas giants deep inside them, tens of thousands of miles below the clouds. Here is where things really get going. It's a place so extreme that it goes against the natural. Most of the new planets we find orbiting faraway stars are huge gas planets. They are so big that Jupiter seems small next to them. Nobody knows what happens inside gas giant planets, whether they are in our solar system or far away. That Jupiter's thick atmosphere goes down 40,000 miles, and we can see bands of gas moving at high speeds that make violent storms on its surface. But we don't know what's happening far below the storms. NASA sent the Galileo spacecraft on a 14-year trip to Jupiter to find out. On December 7, 1995, Galileo sent a probe into Jupiter's atmosphere, which it did at a speed of 160,000 miles per hour. As it fell through the thick air, the parachute slowed it down. It saw lightning in the clouds and 450-mile-per-hour winds. The probe transmitted data back to Earth for 58 minutes. What happened to the Galileo probe that we dropped in? It didn't hit anything. It just kept falling into Jupiter's environment, and the pressure kept going up and up and up as it fell. It measured pressures 23 times higher than on Earth and temperatures over 300 degrees higher than on Earth. When you're in the environment of a gas giant and go deeper and deeper into the soup of hydrogen, which has no solid surface, it can still be very heavy, and so eventually you would be crushed by the overlying weight of the material that's there. Even though the probe only went 124 miles down before it was crushed, it showed scientists what Jupiter's inside looked like. But the dark heart of the planet still remains a mystery. Like some rocky planets, the gas giants have a magnetic field too. Jupiter's magnetic field is 20,000 times stronger than Earth's and so big that it goes all the way to Saturn, which is more than 400 million miles away. Like on Earth, Jupiter's magnetic field keeps the solar wind away from the atmosphere and keeps it safe. When scientists looked at Jupiter's magnetic field, they found that it affected the moons of. The volcanic moon Io orbits only 217,000 miles from the planet. Every Io's volcanoes send a ton of gas and dust into. It gets even stronger because of Jupiter's magnetic field, which makes powerful belts of radiation. And this makes the area around Jupiter very busy in a lot of ways. If you point a radio antenna at Jupiter, you can hear how the planets in the magnetic field interact with each other. Jupiter and Saturn can make auroras without the solar wind. They make their own magnetic fields because they're so big. These auroras show that planets with gas also have magnetic fields. But how do magnetic fields get made on gas planets? On Earth, it is done by a very hot liquid metal that spins around the solid iron core. Most likely, gas planets do about the same thing. But gas planets don't have iron cores that get very hot. They formed around cores of dust and ice, so we don't really know a second moon behind it. We scratched our minds and asked, what could that be? Everyone is aware that Io is lifeless, dull, and uninteresting. And then people realized, oh my God, it's a volcanic eruption. We discovered that the area is engulfed in volcanoes. It is geologically extremely active. There are constant volcanic eruptions, and what they're erupting is a great deal of sulfur, which becomes extremely heated, and sulfur changes color as its temperature changes. It may be red, orange, yellow, or even black. As a result, these images of Io's visage resemble a pizza with various types of cheese and olives, where the small black spots are. Io is not dead, it is alive and growing. There are more than 400 active volcanoes. The largest Pili erupts from a gigantic lava lake. It extends approximately 400 kilometers into space. It would be an extraordinary sight if we could stand on the edge of that lava lake and observe that plume shooting off into the void of space. Pal's eruptions are so massive due to Io's diminutive size. There is nothing holding the lava back, as there is virtually no atmosphere and little gravity. These enormous eruptions make Earth's volcanoes resemble fireworks. How can a moon so small be so volcanic? The answer is Jupiter. Similar to how the moon raises the tides in Earth's oceans, Jupiter raises solid rock tides on Io. The orbit of Io around Jupiter is not circular. Sometimes it's closer, sometimes farther away. Jupiter exerts a gravitational force on Io. Jupiter's gravity stretches and squeezes Io in every 2-day orbit. The ground rises and falls by nearly 300 feet. This pummeling generates extreme heat and enormous pressure. Wherever there are weak spots in the crust, lava erupts. Volcanism is therefore planet scale. In contrast to Earth, where certain portions are active around the plates or in weak areas, this is an entire moon that's one active hotspot. Io is the most volcanism active planet in the solar system. Water would be just like seawater here on Earth, and the chemistry of the water we observe erupting from these fissures suggests that it contains salt. It contains organic matter as well. Therefore, we have identified a location in the solar system where there is a strong possibility that there is life right now in the ice particles. Cassini has detected complex carbon molecules in conjunction with liquid water. They suggest that perhaps life could exist deep within this mysterious moon, and Saturn is possibly not alone. Another one of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system, the only moon with a thick atmosphere, a frozen world, ice as hard as rock, lakes of liquid methane. Yet we may also discover evidence of volcanoes and the tantalizing possibility of extraterrestrial life on this planet. Volcanoes are one of the most destructive forces in the universe, as evidenced by Io's raging conflagration and Triton's ice and nitrogen explosions. Even on Saturn's enigmatic moon Titan, however, destruction can lead to the prospect of life. It has a diameter of 3,000 miles, making it larger than Mercury. It has the thickest atmosphere of any moon in our solar system. There is weather, including cyclones, winds, rain, and even lakes, but the temperature is so low that liquid methane replaces water, and it's loaded with essential compounds for life. Titan has proven to be one of the most fascinating locations in the solar system. It's an active world. It is the only moon with a dense atmosphere, an atmosphere very similar to that of Earth due to the presence of nitrogen. And as it turns out, organic molecules high in Titan's atmosphere. Methane gas reacts with sunlight to produce compounds essential to life. But if sunlight consistently converts methane into organic compounds, why does methane not run out? Methane is abundant in the atmosphere, but we know that it is quickly eliminated by sunlight, so it shouldn't be there. There must exist a source of methane, something on Titan and its methane in a continuous stream. Cassini has spotted what appears to be a crater. Infrared cameras disclose that the crater is surrounded by various types of materials. Scientists believe the green areas may be volcanic, possibly plains of lava ejected from Titan's interior. On Titan, the boiling liquid emitted by volcanoes could be either ammonia or water. Methane and ethane are emitted by Titan's volcanoes, and this is likely the cause of the planet's extremely dense cloud cover and orange atmosphere. This atmosphere likely originated from the outgassing of Titan's volcanoes. Even on a globe as frigid as Titan, volcanoes require heat. On Titan, there are two sources of heat. Radioactive substances heat the interior, and Saturn's enormous gravity caresses the moon sufficient heat to transform ice into water and liquid methane into gas. Could volcanoes on Titan give life a chance to survive here? The chemical reactions necessary for life as we know it require an atmosphere, a solid surface, liquid water, and heat. Volcanoes could provide everything on Titan. If life does exist on Titan, it would be truly alien. It would breathe hydrogen instead of oxygen and possibly swim through methane reservoirs at 300 degrees below zero. There may be oceans of ethane. Possibly there are tidal pools as well as volcanic and hydrothermal activity. Perhaps volcanic heat could produce enough energy to support life on Titan. That's a speculation, but it can't be ruled out. However, we may not need to travel so far to discover signs of life. We may discover it on Mars, a volcanism-rich world much closer to home. Volcanoes are ubiquitous throughout the solar system. Planets such as Io, Titan, and Triton are intricate, volatile, and violent. Once we believed that Earth was the only planet with both volcanoes and life. Now we find volcanoes everywhere, but alien life has yet to be discovered. Volcanoes exemplify the absolute force of creation and destruction. They go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. Volcanic cauldrons are the birthplace of life. Volcanoes create new landscapes. See the atmosphere with complex chemicals. Replace the old with the new. If volcanoes are linked to the processes of life, where is life on other planets? Perhaps the origin of the answer lies in ancient times when the solar system was immature, on a planet similar to our own. This is the planet Mars. 3 billion years ago, volcanoes were active. The greatest volcano in the solar system still stands. The cliffs leading up to it are greater than 6 miles in height. Even Mount Everest would be comfortable in their shadow. This is the formidable Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. Light volcanoes are capable of both destruction and creation.